none for now. This one, the domain is also negative infinity to positive infinity, and or x belongs to all real numbers. Either one is fine. The range, you go from negative infinity, right? The lowest you get all the way to 11. And so it looks like that. So y values that are less than or equal to 11 are acceptable, belong to the graph. Nothing above, okay? So make sure you check that. C and D, I'm running out of space here, but I'm going to make this work. For the domain, I go from negative 50, and I'm trying to scan. This thing will never end, right? Because this curve is going to continue on into the positives. So this goes from negative 50 to positive infinity, or x has to be greater than or equal to negative 50. Okay? Can you see that? You see what I'm writing? Okay. For range, this goes from as high as negative 5 all the way to negative infinity. Okay? So I'm looking at the y values. I don't care about this one. This is the highest I get to, and the lowest I will never get to, right? So this is negative infinity all the way to negative 5. Negative 5 is included. Negative infinity obviously isn't. And in terms of set notation, I'd say y has to be less than or equal to that negative 5. Okay? So there you have it. This one, D. For the domain, I'm looking at the highest I ever get to is 50, right? And I'll never get to the lowest. So this would be from negative infinity, right? You're coming from negative infinity and you're stopping at 50. So it's almost like start, stop. That's another way that you can look at it. Start, stop, right? Where does it start? Where does it stop? So like that, or x would have to be less than or equal to 50. Okay? For the range, you're looking at as low as 30 and as high as, it never ends, right? It just never ends. There's a graph there. So y is greater than or equal to 30 is your set notation. So make a check there, check, check, check. We're doing okay so far? You're too excited, guys. I'm going home. I was like, my class is driving me crazy. Right? They're too loud. I'm just kidding. You're one of the best classes I've had, guys, honestly. So what about this one? There is a start and a stop, right? Like this one doesn't go, there's no infinity here. Would you agree with me? There's no infinity. So we're going to go from negative 6, if I look at the x value, negative 6 to 0. So this is a little bit of a different scenario. I haven't talked about this one yet, but you should have seen it in intro. Right? This one then would be, look at this. This is going to be weird, okay? X would have to be greater than or equal to 6, but less than or equal to 0. Yeah, I know. Okay, so greater than or less than. It has to be somewhere between negative 6 and 0. Does that make sense? Sorry, I made a mistake. I own it. This should have pointed like, it should have been like this. Yeah, because x has to be greater than or equal to negative 6. They always point the same way. Do you notice that? So x has to be greater than this, but less than that. So that's the proper notation. We're going to do more of that when we do word problems, so I don't want to emphasize this one too much, but you should have seen that. For the range, I get as low as negative 10 and as high as negative 3. And I will say this is going to be your saving grace here. You can just state it like this. That's probably the go-to. My go-to is just to use interval notation. Set notation is only if I really have to. Right? So that's another thing here. So in terms of this, you have negative 10 on one end and negative 3 on the other end. Y is somewhere in between. So you go less, has to be greater than or equal to negative 10, but less than or equal to negative 3. Next, last but not least, for the domain, we're going from 50 all the way to positive infinity. So x would have to be greater than or equal to 50. For the range, we're going from as low as negative 10 all the way to infinity, right? So y would have to be greater than or equal to negative 10. There we go. So maybe talk about what happened